Good morning. This is class 2 of our unit 3 microcontrollers. Now, in today's session, we will learn about uh, introduction to embedded systems. And another topic that is discussed here is a comparison of microprocessors and microcontrollers. So, in class 1, we have discussed about controllers, that is, introduction to microcontrollers. What is a microcontroller? Then what are the various types of microcontroller? Now today we will discuss about embedded systems, and then we will just compare a microprocessor with that of a microcontroller. Okay, now here there is nothing much to teach. This it is enough that you can read through the notes that I have given. They have written in a very simple way, so it's easy to understand. So in the last class I have briefly mentioned an embedded system. That is, an embedded system can be thought of as a computer hardware system having software embedded in it. That is, it can either be an independent system or it can be a part of a large system. So embedded actually means something that is attached to another thing. Or we can define an embedded system as a microcontroller or microprocessor based system which is designed to perform a specific task. For example, a washing machine, it is software driven. That is, it has got a microcontroller embedded in it which is programmed, and it is designed to perform a specific task. So similar to that of a washing machine, a fire alarm can also be considered as an embedded system, and its function is only to sense smoke. Embedded system has three components. First, it has a hardware, then it has an application software, and then it has a real-time operating system, which is mainly meant to supervise the application software, and it also provide a mechanism to let the processor run a process as per scheduling by following a plan to control the latencies. That is, its main function is to supervise the application software, and it also provide the hardware, that is the processor, to look over whether everything is done as per the schedule given to it. Okay, so we can define an embedded system in simple words as a microcontroller based, software driven, reliable, real time control system. Now these are some of the characteristics of an embedded system. It is single functioned, that is, usually it performs a specific operation or a specialized operation, and it does the same thing repeatedly. For example, a pager, it always functions as a pager. Next is tightly constrained. Constraint means conditions. That is, it is mainly based on certain conditions. That is, all computing systems have constraints or conditions based on design metrics, etc. But for an embedded system, these conditions are highly strict or tight. Example, design matrix is a measure of an implementation's features, such as this conditions can be either in its design or it can be either on its cost, size, power, and performance. Okay, so that's all about the tightly constrained. Then reactive and real time. Most of the embedded system react to the changes in system's environment, and it computes certain results in a real time basis without any delay. They have given an example here, so you can read through it. Then it is definitely it is microprocessor based or microcontroller based. Then it has got a memory. Since its software is usually embedded in ROM, it does not require any secondary memory. Then it is connected, that is, it must have connected peripherals to connect input and output devices. Then hardware and software systems. Here the software that is used has got more features and flexibility, whereas hardware is used for performance and security. This is a block diagram that representing the various components or included in a embedded system. These are some of the advantages and disadvantages of embedded system. Then this is a basic structure of an embedded system. It has got a sensor. As the name suggests, it measures a physical quantity and it converts it to an electrical signal which can be read by the observer or by an electronic instrument. Then a sensor stores the measured quantity to the memory. Then A to D converter, that is analog to digital converter, as the name suggests, is convert analog signal sent by the sensor into a digital signal, and it has got a processor which is mainly used to process the data to measure the output and store it into the memory. Then DA converter, that is digital to analog converter. It converts digital data fed by the processor to analog data. Then actuator, it actually compares the output given by the digital to analog converter to the actual output stored in it and stores the approved output. The heart of any embedded system is the processor, and it is a basic unit that takes input and produces an output after processing the data, that you all know. Now, a processor has got two essential units, which are the program flow control unit and execution unit. Now, control unit, it actually is a fetching unit for fetching instructions from memory. Then the execution unit has circuits that implement the instructions related to data transfer operation and data conversion from one form to another. Then EU, that is execution unit, includes ALU, arithmetic and logical unit, and also circuits that executes instructions for a program, such as interrupt instructions and all. Now a processor, it will run the cycles of fetch cycle, that is it runs fetch cycle and execute cycle in the same sequence as they are fetched from memory. These are few types of processors available, and their abbreviations and full forms are given here, which you can read through. Next, one important thing is the architecture of microcontrollers. 8051 is an example for a microcontroller. It is an 8-bit microcontroller. So, generally speaking, architecture of microcontrollers are classified into two: Harvard architecture and von Neumann architecture. Then there's when data and code. If both these lie in different memory blocks, then the architecture is referred to as Harvard architecture. If this data and code lie in the same memory block, then the architecture is referred to as von Neumann architecture. Let us see these two architectures in detail. As the name suggests, von Neumann architecture was proposed by a computer scientist, John von Neumann, and hence the name von Neumann architecture. It has got one data path or bus for both instruction and data. That is, for instruction as well as for data, it supports only one data path, or it supports only one data bus. Okay. As a result, CPU does one operation at a time. It is very important. It either fetches an instruction from memory or perform read or write operation on the data. That is only one operation at a time. So please remember that. So an instruction fetch and data operation cannot occur simultaneously. That is, sharing of a common bus that is cannot occur simultaneously. And then its architecture is very simple. That is, it supports simple hardware. It allows the use of a single memory. So this paragraph is important about von Neumann architecture. This is a block diagram showing von Neumann architecture. The other one is Harvard architecture. Harvard architecture offers separate storage and signal buses for instructions and data. It has got data storage that is contained within the CPU, and there is no access to the instruction storage as data. Computers have separate memory areas for program instructions and data using internal data buses, allowing simultaneous access to both instructions and data. Here simultaneous access is allowed, whereas in the other case that simultaneity is not allowed. Then programs need to be loaded by the operator, that is, the processor cannot boot itself. So in a Harvard architecture, there is no need to make the two memories share properties. This is the block diagram showing Harvard architecture. Now this is just a comparison between von Neumann architecture and Harvard architecture. So you can read through it. Von Neumann architecture, as already said, it's simple in design, whereas Harvard architecture is a little bit complex in design. Von Neumann architecture has got high speed and less time consuming. The other one is slow in speed, this more time consuming. So just read these four differences. The other session is about comparison of microprocessors and microcontrollers. Here, microprocessors have operational codes or opcodes for moving data from external memory to CPU. It has got many such opcodes, whereas for a microcontroller, it will have either one or two. Then, microprocessors have one or two types of bit handling instructions, whereas microcontrollers will have many. Then microprocessor or MUP is concerned with rapid movement of code and data from external address to the chip, whereas microcontroller, this rapid movement of code and data, everything is occurs only within the chip. Okay, then microcontroller function as a computer with the addition of no external digital parts, whereas a microprocessor will have additional parts to be operational. That is, for a microprocessor to be functional, it must have additional parts, whereas microcontroller doesn't need that. And in microprocessor, this movement of code and data takes place from external address, that is from memory to chip, whereas in microcontroller all these data movements or code movements takes place within the chip. Okay, so study these differences, it's very important. Plus this is also a few other differences or comparison between microprocessors and microcontrollers. So with this, that's enough for today. So in today's class, each and everything that we have studied is important. So one important question is comparison, or give a detailed comparison between microprocessors and microcontrollers. So you have to write this slide as well as this slide. So all the important points regarding the difference between microprocessor and microcontroller is summarized in these two slides. So study these two slides very well. Next is the architecture, that is von Neumann and Harvard. Just write a brief paragraph about these two architecture, draw their block diagram and give the difference. Then the next one that we have studied is about the various parts of the block diagram of an embedded system, that is what is an embedded system, then what are the various advantages and disadvantages and the basic structure along with this diagram, and explain each of these terms, that is sensor, A to D converter, DA converter, everything like that. Okay, then which are the what are the characteristics of an embedded system, that is another question. So everything that is summarized in today's class can be asked as individual short answer questions or either as essay question as a whole. So today's session is important, so please go through it. Okay, thank you.